will help you to do some data analysis and manipulate the data. So if you want to work with Excel, CSV, databases, JSON, Pandas is the right tool for you. So after installing the Pandas, we'll be going to the import Pandas. So as you all know the earlier how it works, we are importing the Pandas as PD. So after we complete this installation and importing the Pandas, now we'll get to know what is the types of Pandas and everything. So in Pandas, we'll have two things. So let me just go to the thing first. Okay, let me just explain. Yeah, now here you can see that these are the data types you can have in Pandas. So in Pandas, you can have two structures. One is series, another one is data frames. So series is like a NumPy array. So what are the thing you are seeing? NumPy array. It is of single. So if you see this number, it is of 1, 2, 3. So what we'll be doing is so in this 1, 2, 3, this 1, 2, 3 represents a list or a tuple. So if you look at this list or tuple, so this is a 1D array. So I hope you learned what is 1D array, 2D array with the help with the class of NumPy. So what are the files, Excel, CSV, and everything will be working? We'll be working with the help of data frames. So we are having two types of data in Pandas. So these two types of data will be helpful to manipulate the data for machine learning. So the first thing is series, and second thing is data frames. So series, we'll get to know series in detail. So series, keep in mind that what a series means. Series is nothing but a data type. It might be list, it might be tuple or some other thing, but it will be of 1D array. So in this 1D array, how the list is defined, how the tuple is defined. If you want to perform some actions, even NumPy comes under series. Okay, because NumPy is of n-dimensional array. So in n-dimensional array, we can assume that NumPy can be of one dimension. So if we are having some one-dimensional array, this comes under series. So a series is like a single column of data. Okay, so if a series is like a single column of data, it is built on a tool of NumPy array, and it is so efficient, but it acts on the index. So what we're doing is we will having an index. So based upon that, we can have the data types of various data types. But coming to NumPy, it is a homogeneous data. But coming to this pandas, you can have various data types and think of it as a 1D array. Okay, I hope you got my point. So coming to the second thing, that is data frame. Data frame is nothing but a label data which will have 2D, like we'll be having rows and columns. So these rows and columns not like in NumPy array. So what are the rows and columns you're having in NumPy arrays? That might be of a single format, but coming to rows and columns, it can be of multiple formats. Suppose it can be of Excel, CSV, or it can be from JSON, it can be from database or some other thing. So if you want to work with multiple files, data frame is the right tool for you. So first, understanding what is this float cell represents. So first, what I have done is, so for your understanding, I have commented most of them. So in this, you can see a pandas is similar to the NumPy array, and creating panda series. How to create a panda series? First, we'll import the pandas. Okay, as we all have already did this thing, it's not needed, and we need to import NumPy. NumPy is also not needed. So coming thing is s is equal to p.series. Suppose if you want to declare a NumPy, what we'll be doing? If we want to declare a NumPy, we'll use this code, that is s is equal to np.array of 4, 5, 6. Here, this inner bracket represents tuple, and this outer bracket will converting the np.array into x. So input.array will convert the tuple into a NumPy. So what we'll be doing here is, just like which we have done earlier, this tuple is being converted into pandas series. Okay, by series because it is of 1D array. As it is of 1D array, we'll convert this into series. If it is of 2D array, we'll convert it into data frame. So look at this thing. If you run this cell, will give us, so this is assigned as 2, 8, 14 of pandas. So it is of pandas data type. And coming to the print test, you can see this 0, 1, 2 is the index values. These 0, 1, 2 represents index values. 0 of is in the place of 2, 1 is of 8, and 2 is of the index of 2. We will be having 14. So print test. When you type print test will give us the printing this thing, and also print type of s. So if you see, class pandas core series. So pandas is the main library. I hope you understood this. Pandas is the main library. And coming to the core is inside the pandas. So in pandas, we'll be having core. In this module, we'll be having various data structures. So as we have data frames and series. So to define these functions and everything separately, we'll be having a core. This core will perform the functions of data frames and series separately. So in pandas, we'll be having core pandas.core.series. This is a module that contains the definitions and methods of a series object. Suppose if you are working with series, as it is a series, that means in pandas, as we have discussed, we have two things: series and data frames. So if you're working with series, you'll be having a series, because in this series only, you'll be having all the methods and definitions, what series can do, what series can perform, and everything. Coming to this is the thing that defines that what type of data frame it is. Suppose if it is an int, it will define int. If it is a Boolean or float, it will define both. But coming to here, this data type is of series. So that's why it is defined series. So I hope you understood. The first thing is pandas, the main library. So the second thing is coming to the main library. I'll just write it down. So the first thing is pandas. So after pandas, we are having core. This core will this core will separate, then execute the series and data frames. As we are having two data types, series and data frames. After series, this series will help us to understand what are the capabilities and what are the functions that this series function can do. So we have two data types, series and data frames. So what are the functions and limits that series can perform? Those are defined in this. And after that, what is the data type of this? This is series. Okay, so this is the data type that we are performing in this thing. Okay, and coming to s dot values, as you can see, when you print this thing, you will be getting index, and at what index, what value is it. But coming to s dot values, you'll directly see the array like this. So if it is an numpy, you'll directly see something like this, right? So just like when you're seeing an numpy array, just like that, you'll be seeing something here. Coming to s dot index, this will represent the index values. By default, you will see these things. Okay, if we don't have any index values, this shows the row labels and what are the labels that were present for the rows. Okay, if there is nothing, by default we'll get the range index. For everything, we'll get the range index. And also this says that star 0, 3, 1. So what is 0, 3, 1? This is 0. Okay, this we have 2, 8, and 14. 2, 8, and 14. So here it's a 0 index, first index, second index. So coming with a count is of 1, 2, and 3. Okay. So what is the things? We are starting at 0 and stopping at 3. But what are the step? This step indicates that what is the difference between indices. Suppose this is at index 0, this is at index 1, and this is at index 2. What is the difference between every index? It is of 1. Okay, this will represent the step. Suppose if the step is of 2, then we'll have index of 0, index of 2, index of 4. Okay, then one index is being skipped. If the step is 3, then we'll skip 2 indices and we'll get 0, 3, 6. I hope you understood my point. I'll ask my team and I'll provide the sample of certificate in next class. Don't worry about that. And guys, it's a small request that I want you to share some emojis in the session. Whether you understood the topic or not. If I am telling the session and if you didn't understand the topic, I might skip the topics which you didn't understand. So if you give some emojis that you didn't understand, like thumbs down or some other thing, I'll get to know that you didn't understand the session. Then I'll come back to the session, like topic which you didn't understand. Guys, give me some emoji reactions in the chat. So if you give the s dot values, it will call the values what are present in that. And if you give the s dot index, what are the index names and what are the row names and everything. If there is nothing, by default will give us range index, and also start, stop, and step. Start is a start index, stop is a stop index. So as you all know in Python, if you give a count as 3, it will take until 2. So if you give on the count as n, it will take until n minus 1. So that is the reason we're giving the stop as 3. Okay. So the step is 1 because the difference between indexes is 1. Okay. Then going to the next thing. That is, as I have discussed that Python, not the Python, this pandas will not only contain numerical, we can also store the characters. So, but when you're storing characters, it will show that d type is equal to object. Okay. In the previous class, we have changed the d type. Right? D type is equal to object, but now d type is equal to int, which you have typed in the previous class. But now in this class, we'll see that d type is equal to object. So that is because of this characters in pandas. And also, you can see that panda series such A, B, and F are being loaded into pandas character series. And you can see the type of character, the panda score series. Here you can see that this entire represents that this is of character series. Now coming to the second thing, that is data frames. Now we are entering into the main topic that we'll be using in handling the files. So when you want to handle some data files, when you want to work with some data files such as .csv, Excel, or some other files, then you will be using the term called as data frames. Okay, data frames is mostly used in data structures for data analytics. Okay, when you want to perform some data analytics, data frames is used, and now you'll be having some meaningful understanding why pandas is used for data analysis. Okay, so first thing we'll be doing is, I hope you all know what is the type of this thing. It is a dictionary type because typing this as key and these are the values. Okay, you'll be having one key and multiple values, and the key will be unique. Okay, if you have name twice, it will not accept. Let's check the thing. Okay, we are typing what is the type of this thing. It is accepting the type, but when you want to perform some actions, it will tell that the key is being repeated twice, we cannot accept. So the key and values will represent a form is called as dictionary. So if you want to perform some operations in dictionaries, and if you want to convert that, can directly convert using pd dot data frame. Remember this thing. So in the place of type, you directly write this thing, pd dot data frame. So when you write this pd dot data frame, so this will convert the dictionary into a data frame. So if you run this thing, it will give the dictionary in this format. So take a look at this thing. I'll give you a few seconds to understand this. So if you can see this dictionary, the dictionary keys like name, age, occupation becomes the column names. So the keys which are there that will become the column names, and what are the values that are there in the dictionary will become the row names. Okay, for each. So that will become the row values. And when we pass this dictionary into a data frame, the function called as pd.dataframe. When you want to convert it into series, we'll give it as pd.series. Okay, based upon the data type, we'll give the name. If it is series, we'll give that as pd.series. If it is of data frame, we'll give it as pd.dataframe. Now we are importing data files as pandas data frame. So how to import data, like how to import the files, that we'll be learning in this section. So what we'll be doing is, we can get the files from Google Drive. Okay, as it is a Google Colab, it will support Google Drive. So what I want you all to do is, you can log into your Google Colab, and you can log into your drive, and you can mount the drive. Mounting the drive means connecting your drive. So if you run this cell, it will ask you to connect your drive. Okay, this will give you permission this notebook to access Google Drive. If you give this access as connect to Google Drive, then Google Drive will be connected to this thing. As I didn't give the permission for this thing, it will give this way. So what I'll do is, I directly get my file from this path. Okay, so where do you think this path is? It will be here. So how to get the file here? Into upload. Okay, you can see that some file is being uploaded and I'm just now upload. You need to click on this icon. Okay, this is your Google Colab. In this section, in this sidebar file section, when you click on this, and when you click on this upload icon, you will be seeing a small window showing the files which will be there in your local desktop. So when you click on the marketfact.csv and click on that copy path. So if the path is different, we'll just change this thing, remove this thing, and give it as this. So now if you click control click, it needs to show that we are having the path. So when I take this thing, when I run this thing, it will tell us that this path has been read. So this cell will take the file from this path. Okay, as I mentioned the path, this file will be taken from this path. Now what we'll be doing is we'll understand what is the type of this market underscore df. So it's saying that pandas.core.frame.dataframe. So previously we have seen that it is of pandas.core.series.series. Okay. The pandas.core will be same because until pandas.core, in this core only we'll be having series and data frame. But coming to the series, this series will define whatever the functions this series can have. So this series is a data type name. Okay, now coming to this thing, you can see that this is a this is a frame which defines what are the functions and features that this data frame can do, and this is a simple data frame name. Okay, when you type the data or you go to the function and go like ask it is what is the data type, will just give you integer, boolean, character, or some other thing. No, but coming to this pandas, it will give you four things. That is pandas, that's the main library from where it is coming. Core, it is the second main thing from where it is coming. That means in pandas will be having core. In this core, it will explain that in this core is responsible for functioning all the series and the data frames. Okay, now coming to this frame will define that is it the functionality of frame or is it the functionality of series. So if you are using some series, it will tell that what are the functionalities you are using. It is from the series functionalities. Okay, now as you're using the CSV file, as I've already discussed that if you want to work with CSVs or Excel files, then we'll use this data frames. Okay, as it is the functionality of the frames, it will call it as frames. And at last, we'll see the data type. Okay, now we'll be performing some data cleaning. Okay, so data cleaning is a first step we'll be doing in the process of exploratory data analysis and also in the process of data science. Okay, so in the data science, so not in the data science, in the real world, I hope you all know how the data will be. It will often be messy, and whatever the data will be getting, it's not clean. Okay, it will have some null values, missing values, duplicate values, and everything. So what we need to do is we need to correct the data. That means we need to have the correct data so that we'll get the correct analysis and also correct prediction and accuracy. So data cleaning will also be a crucial step in this data project because if your data isn't clean, your analysis on machine learning models won't be accurate. Okay, they won't give you the correct answers, and also pandas will give you the easy ways to tackle these issues. Okay, pandas will give you the easy ways for this cleaning and issues. Okay, first we'll be doing is we'll be checking whether the values are present or not. Okay, what we'll be doing is we are printing this statement, print /n missing values per column. Okay, now null values is equal to market underscore df, that is a file name. Okay, remember this thing, guys. Market underscore df is a file name, market underscore data frame. Okay, this market underscore data frame dot is null. Okay, it is checking that market underscore data frame is null or not. Okay, so this will represent true or false. Okay, this will represent true or false, and this thing dot sum will represent how many trues are there, how many false are there. Okay, if it is representing a false, it will not count, but if it is representing a true, it will count. Okay, that means so this will create a data frames for whatever the data frames that is true, it will take it as 1. Okay, so that means if there is any missing value, that will count as 1. If there is no missing value, it will count as 0. If there is false, that means like if there is false, it will not count. So let me just remove this thing. This thing. Let me just run this thing. Okay, now you can see this false, right? So this false represent that df dot is null. That means false, 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 false. Okay, until this in the top 5 and in the last 5. Okay, in the top 5 and in the last 5, every detail is being mentioned. That means there is no missing data, there is no null values, and there is no duplicates. Okay, no, so sorry, there is no duplicates checked. It's only checking that null values. So the function is only is null. So in the top 5 and the bottom 5, we can check that there is no duplicates. But if you want to know the overall, if you want to know whether in the overall is there anything, so you can see that in the missing values, order ID, product ID, shipping ID, customer ID, sales, discount, order quality, profit, shipping cost. But coming to the project-based margin, we are having some 63 null values. Okay. But coming to this product-based margin, we're having some 63 null values. Remember the function file name dot is null. Okay. So if you want to know what is the sum of the null values we're having, we need to place dot sum. Now what we need to do, we need to drop the null values. So what we'll be doing is market.df. This is a file name. Drop now will drop what are the values that is having null values. So if the any rows or columns is having null values, it will drop those values at particular row and column. Now what we'll be doing is when you run this function, this null values will be dropped. So now we are checking duplicate values. Now if you check these duplicate values, print duplicate rows. Okay, now we can see that duplicate rows is printed, and after that market.df is a file name duplicated. That means if it's duplicated, give it as true. If it is not duplicated, it will give it as false. So if the sum is true, then only it will count as 1. If the sum is false, then the count is 0. Okay. Now as we have given the output as 0, that means there is no duplicate values. Everything is false. Even now you can remove this sum and you can check this. You can see false, 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 false. Okay. Now if you put at this dot sum, it will represent this duplicate rows is equal to 0. Now we'll be having some scenarios where will be their order date. So this order date will not be in date format. Suppose what are the functionalities you can have using date is, you might think that converting the data type is not a big issue, but if the data type is of wrong format, suppose if the data type is of date and you have given numerical, then what are the operations we'll be having, what are the functions we'll be having in data type date will not be performed. That is just like this thing. You can see this thing. So what are the functionalities that are there in frame that can only be performed when we have data frame? So what are the functionalities that are there in data type? So specific data type, suppose imagine if there is a type of date, okay, date time data type. So in this date time, what are the functions I can perform that can only perform with data time? So if I give it as numerical, I can miss out, like I can miss out those operations. So what I'll be doing is, if I run this cell, it says that if order date in market underscore df dot columns, market underscore df dot columns, if we have this column, then pd dot to data time. That means we are converting this to date time. Okay. If we are converting this, if it is converting, then it will convert. And also here also we are giving this as dot as type as string. So I hope you all know this thing. If we represent this as int, it will convert into int. So if we want this to convert it into string. So product ID will have numericals and also alphabets. So what are the things you are doing? We want the data type to be converted into string. So we'll directly represent dot as type of string. We'll directly run this and we will get to know. So now what we're doing, we are just reading and summarizing the data frames. So what are the data frames we are having? We're just reading it and summarizing what are present and what are not. So make sure this is a file name, market underscore df. This is a file name, and dot head will represent the top 5 rows. What are the top 5 rows that are present in the table that you can see here? So you cannot overview every table. So what you will be doing is, you will have this dot head. In this dot head, you will be seeing what are the rows are there, what are the columns are there. You will get to know the data frame, what are the data set you are being like performing some operations, and what are the data frames that you will be performing with. So when you want to perform some operations, you need to first check what is the data you'll be having in this sheet. So first go for this operation called as market underscore df. There is a file name dot head. In this head, you'll be seeing the first 5 rows. So with this first 5 rows, you will understand. But coming to the last thing, that is the market dot df underscore tail. So this function let us know the last 5 columns. Sorry, the last 5 rows. So when you get to this last 5 rows, you will get to see that is there any incorrect data in the last 5 rows. Okay. Suppose you will be having correct details in the top 5, but coming to the last thing, you'll be having some error values. So just like when you're writing some exam, you'll be writing neatly for the first few pages, but coming to the last pages, when you're not having any time, you might not write every answer properly. So just like that, the data which was being entered by humans also, there might be some mistake that in the last sheets of data we can have some errors. So we need to check that whether the data has some errors or not. Okay. And also the next thing is file name dot info. This is the file name and dot info. This info will tell us everything we need to know about that file. Okay, if it is a CSV file, if it is a JSON file, if it is a database file, what are the file it is, we get to know the info about the file. What are the file attributes are there? What are the columns? What are how many rows we are having? So you can see that we are having 3,336 rows, and everything is of object data until this thing. And coming to sales and discount, they will be mentioned in numerical, so it is a float. Order quantity is of int, profit, shipping cost, product based margin, everything is a float. Okay, we'll get to know the data type, we'll get to know what are the columns are there. Also, what is the null count that is present in the column. So if you look at the table, before we used to have some null values in the product based margin. Before, when you click on this is null, when I run this thing, you used to get that you had some null values at this thing product based margin. But the next value, what we have done is we have this on this process where we have dropped all the null values. So after running this cell, when you go back and run this cell again, you'll see that the product based margin has 0 null values. That is what you are seeing here, that you're having no null values. Coming to describe. So this describe will give you the description of the, and if you look at the description, it will tell us the count, mean, standard deviation, minimum, Q1, Q2, Q3, and max. Okay. So coming to this things that were mentioned. So count will tell you the count that is there in this. So we have 8,336 rows. That is the count, and this mean states that we have this mean for every column. So for the sales column, this is the mean. For this discount column, is the mean. Okay, and standard deviation for every column that is being mentioned. Minimum that is being mentioned in every column. So coming to this 25%, this is mentioned as Q1. Okay, this is mentioned as Q1. Q1 is nothing but the 25% of the data. So this 25% of the data, that means the data will be near to this 25% of data. So the entire data, if you take this entire data, this value, what is mentioned here, that is 141.971625. This data is the nearest value to the 25% of the data. Coming to this 50% of the data, it is just like the mean value. Suppose if you're having, let's give an example. Suppose if you're having a list, I hope you all know how binary list works. Suppose if you're having a data of 2, 3, 5, 7, 8, 9, and 4. Okay. So if you want to perform some operations, first in binary list, what you'll do is you'll find out the middle value. Okay. You'll find out the middle value. What is the middle value that is it? That is being chosen as mid value. Data from this mid value, and later from this mid value, we will identify whether the value which we are looking for is in the left side of the mid value or is it from the right side of mid value. So just like that, this mid value is the Q2, that is the median. So what is the middle value that we are having? That is what is the mean we are having, that will be considered as the middle, like the 50%. So this comes under Q2. So this 3 will comes under 25% and 9 will comes under 75%. Okay, that means from this, from the entire thing, if you look at the half, that is 7. So this 7 is considered as the Q2. Okay, so from 7, if you look at the before 7, we have 3 things, that is 2, 3, 5. The middle of 2, 3, 5 is 3. Now this 3 is considered as the middle element of 2, 3, 5. And coming to the last thing, that is 8, 9, 7. That is the right side of 7. Now if you want to consider what is the middle element, That means we have 9. So what are the data we are having? We'll just organize the data in a, sorry. So what are the data we're having? We'll organize the data in a sequence format. We'll organize the data in arranged order. So after this arranged order, we'll check the 50% of data. That means we'll check the middle value. After the middle value, we'll check what is the 25% of the data, what is the 75% of data, and we'll mark that as Q1, Q2, Q3. And coming to the shape, we'll get to know the size of the sheet or the file which are performing operations with. Suppose if you're having this thing, this is the rows. That means we're having 3,336 rows and we're having 10 columns. You can see that here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. We're having 10 columns and we're having 3,336. And this is the values. There might be some missing values. Okay. After we have removed the missing values, we have removed 63 missing values. So we can get to 3,336. So the next thing is indexing and selecting data. So I hope you understood what is shaping. Shaping is nothing but understanding the shape of the file. The shape of the file represents how much data we can inject into the file. That is, we have 8,336 rows and 10 columns. So that is the shape of the file. So now that our data is loaded, how do we get to know what is a specific part of the data? So that is called indexing. Okay. How we will get to know what is the data? So it's similar, just like selecting items from list. So suppose if you want to select some items from list or numpy arrays, just like that, we'll be having, but some more options we'll be having in this thing. Okay. We'll be having more options as it is pandas. Okay. We'll be having for rows and columns together. Suppose if you look at this thing, I hope you all know how slicing works. Slicing works in a way where you'll be having this is start, this will be stop, and this will be the step. Okay. Now what we are doing, we are taking 2 as start. That means we are starting from 2. In the middle, we are having 7. That means at 7 we are ending. That means, as you all know, if you want to end at 7, we'll get until 6, because in Python, if you want to start from n, you'll get n minus 1 only. Okay. If you mention here 8, we'll get until 7. Sorry, and I'll make this as a comment. Okay. 2, 3, 4, 5, 6, 7. Okay. Now, if we mention here step, the step will be 1. That means for every, what we'll call, for every increment, that means we'll have a 1-digit increment. Okay. If I represent, I'll just show you this thing. 2, 3, 4, 5, 6, 7. There is no change. But when I represent 2 here, 2, 4, 6. Okay. We're having 2, 4, 6 because we are having 2-digit increment. So the difference between the index to index is 2, 2, 2. So if we remove this thing and if I run like this, now I'll be getting 2, 4, 6, 8, 10. That means I'm getting integers, but I'm getting indexes, but I'm getting a gap between the indexes, that is 2. Now you can see I have the index until last thing. So this is how indexing and slicing works. So this is how indexing and slicing works. Now what you have done earlier, we're performing again. So can you please tell me what this represents in the chat box? I just posted in the chat also. So what is this market underscore df 5 colon nothing colon 2? So from 5, we'll go to until last with the step of 2. That is correct, guys. Thank you for your response. Now we'll be selecting columns. So how we'll be selecting columns, we'll get to know this thing. So there are two main ways to select a column. That means we'll directly go for this thing. That is, we are assigning market underscore DS. This is a file name. And in this file name, we are having a column called as sales. So in brackets, we'll represent sales and we'll assign this to something. So this, by this method, we'll select a column. Okay. By this method, we'll select a column and we'll run this thing. So in this, you can see that if I give sample is equal to market underscore data frame of, let me just give another thing, that is as I have sales, I'll give discount. So let me just copy this thing. So in discount, I'll give this. Okay. Now we are getting now you can see I'm getting the head of this thing. Now I can get the tail also. So tail represents the last 5 and also I can get the info. Okay. And also I can describe. So guys, remember, when you know this pandas library, you can play with these pandas. You cannot perform some operations. What I'm literally doing is I'm playing with the library. What are the things you are performing? You can see multiple operations and multiple answers. So this is a fun game. Want you all to perform this game after this session and also in the tomorrow's class. So here also we can directly use this format to get this thing. That means we are getting the file name. In file name, after file name, we are taking a closed brackets, like we're taking a box brackets, and in box brackets, we're defining the column which we want. So there's another way where you will directly get that by using dot of the column name. Okay. When you get this thing, you directly type the file name dot sales, file name dot discount, file name dot product ID. So directly you will get the column names and column IDs from this thing. Okay, now you can get the head and everything. So now this is the process to select one column, but now we'll be doing something called as selecting multiple columns. So just like we have done this thing, market underscore df dot discount. Now what we'll be doing is we'll type column, we'll type a comma, and we'll get sales. Okay, just like that, we'll describe the multiple columns in a single list. So you can see that we are having two brackets here and we are having a single bracket here. That is because in this thing we are having a list, and for this list we are converting it by using market underscore df. This is a file name. In this file name we'll be having this list. In this list we can convert the list into multiple columns. Okay, we cannot directly mention column names because column names will not be converted, as it is not taking the attributes of multiple attributes. In column names you'll be having multiple column names. So if you want to mention multiple column names, you can either give it as a tuple or give it as a list. So what I'll be doing is I'm giving it as a list. So in this market underscore df, so I'm considering a list and I'm giving all these list names. Sorry, I'm giving all these column names. And I want to know the head. Now what I'll be doing, I'll just simply run this thing. And now I can have some functions to suggest charts and also perform some mathematical operations. That is with the help of pandas. And also, what is the data here? This is the data of a data frame. You can at least see it here, data frame. And when you run this thing, it will say it is of pandas core frame data frame. And position label based indexing, this is a concept that will tell you how to get values from the sheet or from the what we'll call from the files. How we'll perform is we'll get the values by from index location. In this, you will be having two ways, that is df.iloc or df.loc. In this, df.iloc represents index locations. So based upon the index values, we'll get to know. Suppose if you want to fetch value from 10th row and 12th column. Okay, now I'll be going from 10th row and 12th column. Now what are the values? 10, 12. Okay, now if you want to fetch values based upon the column names and row names, then you'll be directly giving the row names and column names. That is why look like a label based index location. So let me just show you how it works. So here market.df underscore head will give us the head of this. Now what I want to do is market underscore df dot loc. Okay, in this loc, I'm getting the values from second row and seventh column. What is seventh column? 1, 2, 3, 4, 5, 6, 7. Okay, now what we'll be doing, we'll getting the values from second or seventh column. Okay, that is by our human mathematics. But coming to the computer mathematics, this will be like counted in a way like 0, 1, 2, 3, 4, 5, 6, 7. Okay, coming to this rows 0, 1, 2. So you can see that we're having a numerical called as 0. We need to count from 0. I was just testing whether you got my point or not. So in the previous session also I told you that we'll be counting from 0. So I was checking whether you guys were listening to the class. So I can see some responses that you guys were listening. So as getting back, we can see that this is a number which we are getting, that is 1148.9. Okay, this states that we are getting the value from second row, that is 0th row, first row, and second row. And after that, we are getting the row like value from 0, 1, 2, 3, 4, 5, 6, 7, seventh column. Okay. Now you can also get with the help of so you can see that we're getting this with the help of from the table. You can understand 0, 1, 2, 1, 0, 1, 2, 3, 4. Okay, this is the sales value. Now coming to the next step, market underscore df dot 2 comma 4. If you run this cell, you're getting an error because you're not defining anything. Coming to here, you're defining something. Okay, if you define dot loc, it might run, but it will also give you an error because the in the location we are not we are not getting any column name and row name is 2 comma 4. But if you give it as iloc, then it will give you the output as 470169. Okay, the first error you will be seeing is because you didn't give any confirmation for the system. So the system will not think whether it might be from iLocation or location. If it goes for location, then it needs to understand whether you have some column names and row names with numericals. Sometimes you'll just mention the column names as 1, 2, 3, 4. Okay, now the machine needs to understand whether it is a column name or whether you are getting the index number. So for that reason, do not give some confusion to the machine, as we are already having the confusion in our daily lives. So what we'll be doing, we'll just give more understandable text for the market underscore df dot iloc or loc. Loc represents location based indexing. Iloc represents index based index based locating. So coming to this, it states that we can also get, so if you look at this, to give something like this, so in the previous thing also, what you're doing, market underscore df dot ilc 2 7. What if you do this performs the operation, you'll just get the 3 7. But when you mention 3 7 9, that is, if you want to get multiple row element, suppose if you want to get multiple rows, then it is not possible because this will have too many indexes. Okay, this will not have 3 attributes. This function which you are performing, this will not have multiple attributes, just like you are having. What you'll be doing, you'll just convert it into another list. Now if you convert this into another list, now what we'll be seeing is row number 3, row number 7, and row number 9. Now this is a operations we'll be performing with market underscore df dot iLocation. So when you want to look at the file for some data, then you can use this iLocation or location. Okay, when you know what is the index, at what index you are having some data, when you want to look at the data, then you can directly use iLocation. Or when you want to use the rows and columns names for identifying data, then you can go for LOC. I hope you understood until now. Give me some responses, guys. And in the same way, if you didn't specify .iloc, you'll get some errors. Okay. Now, if you specify something like iloc, you'll get some output. And also for dot location, also we don't have this thing. But as the row values are of this 3, 7, and 8, okay. But if the row values is of like what we call string type, character type, or some other data type, we cannot get because the row values might not be the same as index values. If they are same, we'll get the same. If they are different, then we'll use iLOC. Okay. Coming to market.df underscore head, this will again show us the top 5 elements, and this market underscore df dot loc of 5, it will give us the 5, and it will tell us what is the info of this 5. Okay. For fifth row, what is the order ID, what is the product ID, and for fifth row, what is the items you're having. Okay. Now, if you can see, as we have discussed earlier, here 378, if you give it as if you give it as this thing, we'll get, because the row numbers as given as 378. Okay. Now assume if these row numbers are A, B, C. Now if you perform 378, then we will not give, because the row numbers are matching with this thing. Okay, whether the location will map whether it is there or not. Okay, when you use dot location function, it will map whether it is there or not. If it is there, then it will give you. If it is not there, then it will not give you. Okay. So it is just like slicing. So going from 4 to 8, and there is no step. That means if it is no step, then it will directly consider as one step. But if it is 4/8/ some other thing, then it will go with the steps. Now we'll be learning that concept called as slicing. So how slicing will work, how we are doing, and why is the use of slicing. I hope I'm not boring you guys. So what we are doing until now is just we are playing with the Python. We are playing with pandas libraries. So this concept is summary of how this slicing and the what we'll call this thing. So how the slicing data frame works. So what we'll do is let's consolidate all the ways to slice and dice your data frames. Okay, that means picking specific data based on rows and columns. So we'll be picking some specific case rows and columns, or even conditions. So what we'll do is we'll just select a column and get a column as a series. So we just take a column, that is sales underscore column is equal to market underscore df of sales. So here we'll be having another way to write this thing, that is sales is equal to, so we'll just keep another s for no variable name conflicts. So just like the above, I'm not doing the same. I'll be doing dot and I'll be giving the name as sales. Okay, now I'll be getting the same functionality as the upper thing. Okay, this and this is nothing but the same, but only what you're doing is some other type of functionality. Now, if you just comment this, it will work fine. Sorry, I need to change this thing. Then I had some naming error. I didn't change the previous file name. The previous file name is sales underscore column. So sales underscore column is mentioned as this. So I forgot to change this thing. Okay, now we get this thing. So remember one thing, whatever the column selection, nothing matters. Okay, the function matters. So sales is equal to market underscore data frame dot sales. So print sales column, sales dot head. We are getting the sales and we're getting top five of sales. Okay, if we give it as tail, it will give us last five. If we give it as info, it will give us the info. Okay, I hope you understood this one. And also, if you want to know multiple things, okay, if you want to know multiple things, just like that you're doing, just click on sales underscore profit underscore df. This is a file name, not a file name, it's a variable name. Here we are getting two columns. Here we're getting two columns. So if you're getting two columns, you'll just use this thing. And if you want to use dot head, dot tail, dot describe, dot info as your whatever the want. So perform these operations for two columns. Now we are using slicing. Okay. Now we are using slicing. So for the first five rows, market dot underscore df dot ilvoc. This is the index location. That means for the 0th row, that is the 0th row to this 5th row, we are performing these operations, but there is no step. Okay, though whenever the step is not mentioned, then we'll use 1 by default. So 0, 1, 2, 3, 4 is mentioned by default. That is the thing. And also this is being mentioned again. So this is conditions. Okay, we are selecting a column, we are selecting multiple column, we are selecting row by index, we are selecting rows by conditions. So for this we will be using df, and in that we'll be converting this, and like suppose we'll be getting a column. So for getting a column, we'll be using df of sales. We are converting into data frame. We're checking whether the data frame is greater than 1000 or not. After the value which we are getting, we're changing the taken into data frames. Okay, we are not getting a single value. We are changing the values again into data frames. For that, you'll be functioning, you're performing this function. You can see high sales is equal to market underscore df of sales, and if it is greater than 1000. So this data frame of sales for this sales column, if it is greater than 1000, it will give it as let's see where the sales is. Okay, if it gives the value, if not, it will not give the value. So we have got around 5 values. So these 5 values have been converted again back to data frame by this function, market underscore data frame, that is outer function. 4 is completed. Now what we'll be doing is using i.loc and using ilvoc. Okay, these are both under the same. So we'll be learning about both them by using a single thing. So LOC example, in this LOC example, you can see this is the index, this is the stop, this is the start, this is the stop, and the step is not mentioned. That means we'll go from 0, 1, 2, 3, 4, 5. Sorry, we'll go for 1, 2, 3, 4, and we'll do that for sales and profit, because here it is mentioned that we'll only perform for sales and profit. Now we'll be running this .loc for rows 0 to 5 and sales and profit. Now we'll be using the same thing. So why do you think we got 0 to 5? Okay, I've already told you, when in Python, if you are using 0 to 5, we'll only get until 4. Okay, that means if you are using in Python for n, you'll get only n minus 1. But why to 5? Because in LOC, it will not take it as a number. Okay, it will take it as an object, and it will try to map whether the object is present or not. Okay, Now this object is nothing but a character. It's not a numerical up. Okay. So when you're writing, it is numerical. But when the machine reads it in the LOC function, everything is not mentioned as numerical. But only in ILOC it is mentioned as number. So here until 5, you can see only 4. Here it is given as 5. You can see it is as 4 because here it will taking that n is equal to n minus 1. But here it is mapping the row names. That means here starting from 0th row, that is a 0 no name, to 5th row name. That is 5th row name is 5. So 0 to 5 we are getting, and coming to this ILOC, we are getting from 0 to 5 only. And this 0 to 3 represents column 0, column 1, column 2. This is the indexes, not the row names. Okay, and we are finally getting the Boolean values. That means we are checking if the sales is greater than 100 and market difference of a profit is greater than 0. Only when we are getting the true values only, then we are printing this thing. So I hope you all know this AND operation and OR operation Python. When two conditions are there, only if two conditions passes the test, then only we'll get the result. If one of that is true and one of that is false, it will be returning as false. If both of them are true, we'll be getting true. If both of them are false, we'll be getting false in the end condition. But coming to the OR condition, both of them are true, we'll getting true. If one is true, we'll get true. If one is false, we'll get true. But if both of them are false, we'll get false. So in the end condition, we'll only get true when both of them are true. Okay, that means what are the rows we have mentioned here? They all have market sales of 500 and profit of greater than 0. When both of these conditions are meant true, then you'll print the statements. Now in the next step, we'll be merging and concatenating data frames. So how to merge data frames? We'll be having a function called as pd.merge. Okay, we'll be having a function called as pd.merge, and also we'll be having a function called as pd.concat. So using these functions, we'll be merging the both the things, that is we'll be merging, and that is the end of this sheet. Okay, I hope you understood. Give me some emojis, guys. I cannot understand that you understood the session or not. So how this concat and merge works is, suppose if there is two tables, in these two tables we'll be having a common column. So in these two tables, suppose in one column I'll be having the product details. Suppose if I'm having a product details, I'll be having makeup kits, shoes, clothes, bikes, phones, and everything. What are the products that are available? All these products are there in this product table. Coming to this is the annual income table. From what product we're getting the income. So from these two things, we're only having single column that is common within two tables. So this column is product ID. So for every product, we'll be having a product ID, and for every profit from each product we got, we'll also have some product ID. So mapping this product ID is a common thing. Just like in SQL, we'll merge this in join, inner join, and outer join, right? Inner join, left join, outer join. So based upon this thing, we'll be merging the two tables, or we'll be concatenating two tables based upon the user requirement. Okay, if you want to merge, you can directly use the function pd.merge by using this product.id as a common column. And also, if you want to concat, also you'll be using this product.id as common column, because you're having product underscore id as a common column between product table and annual income table. Suppose if you're having customers id as a common, suppose if you're having customers table and this table, if you want to map these two things, customer id will act as a common column. Okay, based upon the what column you're having the like common elements, then you will map that thing. Guys, we'll be getting the recordings, don't worry about that, and take a break for 10 minutes. I hope it is okay for everyone. I can see someone is raising their hands. Please tell me the issues, whatever you're facing. Guys, give me some response that do you want any break or not. If there is no requirement for any break, then we'll directly go for EDA. So if you want any break, then we'll take a break for 10 minutes and we'll get to the topic. Guys, I hope you can see my updated collab screen. Give me some response, everyone. I'm just started to connect my terminal. So I hope you all are back from the break. We'll try to drag the session for another 10 minutes. It won't take much longer. So we'll be discussing about the EDA. So this is a crucial step which will be performing after the data manipulation and data cleaning. So after cleaning, what you'll be doing is you'll be performing some like what we'll call this. You'll performing some operations. So this operations after performing, you'll get some visualization. So by visualizing something, you'll get to know that what are the data you're having. This data have some missing values, null values, or this data, how much of the data is some categorical, how much of the data is numerical, and everything. Okay. So to represent also, it will be a good thing to visualize the representations. So we'll perform the EDA for the next step, that is also called as exploratory data analysis. So this exploratory data analysis, so in this EDA is about the understanding of our data. It's a crucial first step, and any data which you'll be performing before you can solve a case, you need to gather the clues first. Okay, if you want to find out what is happening, you need to have some clues. So for that, we need to observe the patterns, what it is coming, and also need to understand the context. Okay, we need to understand what is the table, what is the data we're having, and everything. So that exactly what we'll do in its EDA. So why this EDA is important is we'll understand what is the data, how data is performing, and we'll understand what is the outliers. Suppose what our outlier means. Let's visualize something. Okay, I'll try to share my whiteboard. I hope you can see my whiteboard. So in this, as I have discussed, if these are the data points, suppose if these are the data points, if our machine learning algorithm goes with the data points like this, these data points are the points which will be training. So that means we'll include these data points into our training and we'll complete the algorithm. But if you're having data points like this data point will deviate us from the main task. Okay, this data point will pull this line like this. So we'll miss some of the data points that are being targeted for the output. Okay, this is a outlier. This outlier represents that what are the data points which you're having. If everything says A, this outlier says B. Suppose, let's take an example. If you are a group of 5 and your group like to do some activity, so you will if you ask some, if you have a poll between your group, someone says movie, someone says like doing some activities like playing cricket, some other thing. If everyone says movie, suppose in a group of 5, 4 members says movie, and this one person says he want to go to home, he want to hang out with some, want to go to some restaurant and hang out there. So this person is called as outlier. That means he is not at the same interest with the other persons. So just like that, what is the like sorry is the thing which we are having everything. So based upon this interest, we'll have a line drawn like this. So if we're having a line here, oh, if we have a line here, so this point we'll try to take the line away from these data points. Okay. Suppose if you're having a points like this, and if you have a point like this, generally the line would go like this. But for this point, we need to go like this because we need to include all our points. This is called as like underfitting the data. Suppose if you're removing some points, so do not underfit the data. We need to calculate the model with every data point. So for that, we will go with exploratory data analysis to perform the outliers. So as we have taken the example, as we are having a group of five, everyone wants to go to the movies. One wants to go to some cafes or some other thing. So this person who wants to go to the cafes is an outlier. So he's a culprit who is being as an outlier, and he will be having some separate interests that are not likely with the group. The main features of this EDA is that we'll be discussing in this session. As you can see here, that is the first thing is univariate analysis, bivariate analysis, and multivariate analysis. Okay, so univariate, bivariate, multivariate is you need to understand it with a single example. That means analyzing single variables. Suppose in the previous table we have discounts, sales, everything. So if you are performing some activity with, if you're performing some analysis with discount, that is called as univariate. If you are performing some analysis with discounts and sales, that is bivariate. If you're performing some activity with say, discounts, sales, and products area or some other thing, then it is called as multivariate. Okay. So if you're performing the analysis with single column, it comes under univariate. If you're performing the analysis with multi columns, that will comes under multivariate. If you're performing with between two variables, so if you're understanding what is the relation between these two variables and how this contradicts the data, everything that comes under bivariate analysis. Okay, I hope you understood this thing. So we'll be working with a small data set. So in this real world scenario, we'll be loading out your own data. For learning purpose, this data set that I'll be showing you, this is a small sample data set. Okay, for this, I am taking a random of from this random, I will be performing some activities. Let's take a quick look at our data set. As you can see that from the head function here, so if you're looking at this, we are first importing the libraries. After importing, we are using matplotlib and using the default shell. And in this SNS is nothing but cborn. So for this matplotlib and cborn, these are the libraries that will be used for analyzing the data. So these libraries will be using for data analysis. So these libraries will help us creating visualizations in Python. So if you want to create visualizations, Matplotlib is a primary approach. But if you want to perform visualizations with low code, that means SNS will simplify creating visualizations. What are the visualizations we'll be performing? SNS will help us to create visualizations with minimal code. Suppose if you are performing with Matplotlib, you need to define height, width, breadth, and what is a visual, what is everything. But coming to SNS, you need to only describe what is the visual you want to perform. Then SNS will directly create a visual for you. Okay. SNS is easy. That means Seaborn is easy to create visuals compared with Matplotlib. Now, after that, we are taking the figure size and everything. Now we are taking the random samples for the data. We are taking the random samples. This random is nothing but getting randoms, and in samples we are storing that. Okay. So here we are creating a sample data set from a demonstration. So here, look at this thing. We are taking in this data. Data is a like a data is a dictionary. In this dictionary, we are taking this age column, education age column, experience column, satisfaction score column. So in these columns, we are taking this data and we are getting some data frames out of it. So for these data frames, we are performing the analysis. I hope you understood this thing. So we are printing 60 is equal to here exploited analysis tutorial. This is what we have like we are written in the cell. And after that also we are printing 60 is equal to, we are multiplying that with, and also now we are getting an overview. So this, for this data we are getting an inserting a data frame. So in this data frame we are getting data age from 22 to 65, education age from 2020, and data experience from 0 to 40, and also satisfaction score from 1 to 10. After that we are printing this thing, and after that we are going for the data overview and preparation. In this data overview preparation, what we'll be doing is we'll be performing some univariate analysis. This is a sample data set for our demonstration. Only we are taking this thing. So first we are checking the data shape, and also for the columns, just like what we have done in the previous pandas, we'll be checking the data shape. So shape is, we are having 1000 rows and 8 columns. So why 1000 rows? Because we have taken the n samples is equal to 1000. And why 8 columns? Because we have mentioned here 8 columns. Okay. Now the columns which are having is this. So you're getting this because you're mentioning the list here. Other than that, you'll directly get that in a format where age will be in the left side, and you will be getting the description for the age, what is the data you'll be having and everything. So the data type, what is the null values and everything. So as you have mentioned list specifically, you are getting that in list format. Also in the like this is a print statement. After that, you're printing the head of the data frame. So for every data frame you're having, we're printing the head. So this is a head. You can see that we're having some poor, excellent, average reviews. After that, we are getting to know the data types. What are the data types we're having? Age, income. So you can see the data types, and we are describing the data. So this is the data. After that, we are getting to know whether we are having some any null values or not. Okay. As I've discussed earlier, if you remove this, you'll be getting understanding of null values, whether they are there or not. So what you'll be doing is you're just getting the sum. Sorry, I didn't mention any function. Now you can see that the function represents that there is no null values. Okay. Now, until now, we are performing the data analysis. Okay. This, after this data analysis, we'll be performing the univariate analysis. This is the pandas part. Until now, just like as I'm a beginner, just like I'm doing ML project, I'm trying to get to know, I'm trying to get to understand my data set. Okay. Now I understood my data set. I can understand what are the attributes are there, what are the column names, how data, like how I can describe my data and everything. Okay, null values, duplicates, and everything. I've worked with this data set. Now I'll be going with this thing called as univariate analysis. Now in this univariate analysis, what I'll be doing is, let me just print this thing. So univariate analysis now. So in this univariate analysis, this is where we'll examine each variable individually. So what are the variables we will be having? Now we'll be individually examining every variable, and we want to understand this distribution. So how it is distributing and everything. So it's like we'll be identifying the outliers, whether it is there or not. What are the potential outliers that we can identify? We are seeing that whether it is there or not. So to start with this, we have separated our variables into two types. One is numerical and one is categorical. Okay, we can look at this numerical vars and underscore. And another thing is categorical underscore vars. So this numerical vars and categorical vars, this represents that one is of numerical. That means what are the numericals are there, we can perform aggregation functions. Suppose if you're having 2, 3, 4, 5, we can perform minimum, that is 2, maximum, that is 5, average, that is 2 plus 3 plus 4 plus 5 by 4. Okay, mean, median, max, everything that we can perform with numerical. But coming to categorical, you cannot perform this numerical, like you cannot perform this mean, median, mode, and everything. Okay, you need to have some numerical to perform this aggregation functions. So that's why we are dividing numerical and aggregation differently. So we are dividing it into two lists. Okay, we are dividing it into two lists. You can see that with the help. So we are dividing with the help of include np number, whatever it is stating at number, we're converting, and whatever it is giving as object and bool. So these two data types will come under categorical. Either if it is objects, that means characters. So characters and boolean values will be coming under categorical. And if it is as include np underscore number, that like numpy numbers will be coming into like this numerical, and also columns will be converting into two list. So if you run this thing, that's it. Now if you print this, you will get to know that numerical values age, income, education years, experience, and satisfaction. So department. So department will be of, if you are working in college, you'll be in computer science department, mechanical, EC, or some other department. Performance rating. This might be a rating of good, bad, poor, or some other thing. Remote work, if it is yes or if it is no. Okay, if I'm a professor, if I'm working in remote, I'll be giving my experience as yes. If I'm a remote worker and if I'm working in college, then I can give it as no. Now I'm analyzing numerical variables first. This is for the analyze. Okay. Now what I'll be doing is now explaining the code. So let's begin with these numerical values. So the fantastic way to numerically analyze these values is by distributing the histograms. So histograms is a plot that will show us different values appear in our data. How different values are appear. I hope you can see this thing. Histogram is nothing but a bar graph kind of thing. So this graph will help us how frequently data will appear in our data, and we can notice how two rows of each variable will affect how other, like how these two rows of data will can affect other data. And the top you can see that we are using matplotlib. You can see that like I'll explain the code later. But coming to this code plot. So now we are using figures axis. Axis is for the part where you will set the like part where you're having the figures. So how much layer will be having figures and everything. So PLT. So whenever you're PLT, it mentions that you're using matplotlib. Okay, you're using subplots and everything. You're mentioning the figure size and everything. Coming to figures title, you are giving the titles. Okay. Nowadays, what we are doing is we are mentioning the titles and everything using matplotlib, and coming to the figures, we are using that using like Seaborn. So you can see that we are mentioning Seaborn approach for the bottom row. We are giving the figures and everything. And in the top row, we are using matplot approach. So now with the matplot, you can see it's a bit more bare bones. That means whatever we are having, we don't have any direct control. Yeah, we have direct control over the bins and colors. So if you can see, we can give the color as sky blue, or we can give the color as blue. It's taking some time. Okay, it's giving the color as time. Okay, so it's giving the color as blue. So whatever the color, whatever the everything, whatever the axis, everything, so we can have a control over the thing. But we can also specify it everything manually. The difficult thing is, as you can have more controls, you need to define more controls. Okay, but coming to Seaborn, if you look at this, Seaborn is a small code. Okay, as we have discussed, Matplotlib is a large code, but coming to Seaborn, it is a small code. In this small code, you can see this is of Seaborn and this is of Matplotlib. So what are the figures which you are having? The first five are from Matplotlib, the second five are from Seaborn. In Seaborn, we didn't describe the color to be red, but by default, it took the color as red. But in Matplotlib, we have defined the color to be of blue. So what are the color you're defining? It can take the color. So now if I declare the color as red, or if I declare the color as lavender, hope let's see if it takes the color as lavender. Okay. So now it's taking the color as lavender. So whatever the color you are giving, it will take the color. And it's a great way to get the overall shape also. But in the Seaborn, what are you doing is you're nothing but seeing the aesthetics here. Okay. Now if you look at these two things, it looks like it's some old formatted way, but coming to this, it's having some line chart also. Okay, it's having some line chart and it's showing how the bars are moving across the timeline over years and everything. So this is the main difference between Seaborn and Matplotlib. The code will be more in Matplotlib. You need to define everything, but coming to Seaborn, you don't need to define everything. Everything will be defined for you. Okay, they will automatically print that thing. And the main difference, if you look at this, you'll be having more control, and in this, you'll be having less control in the Seaborn. So this is a math like analysis for age, income, education years, experience, and satisfaction code. Here we are taking a univariate analysis. That means for every single variable, you are performing a analysis separately. Okay. Here for age column, you're performing separately, income, education year, experience, satisfaction code, you're performing analysis separately. So you can see that key differences are Matplotlib has more control over individual items. Okay. and it requires our manual study, whatever we are having. As I have discussed lavender and everything, we can also discuss the figure size, like the bins, back color, like we can also discuss the axis, font size, and everything. Okay, if I discuss the font size to be 20, the font size will increase here. So everything we need to define in Matplotlib. We're coming to Seaborn, it's built in. Okay, you don't need to define everything. Automatically it will get the define, like it will call that and it will get the features. Next thing we'll discuss is box plots and in Seaborn versus Matplotlib. So in this box plots, these are excellent for visualizing the distribution of numerical data. What are the numerical data we're having? It's the best thing to visualize the numerical data. So especially we'll use the box plots to identify outliers and understand quartiles. So what are quartiles? These quartiles are nothing but Q1, Q2, Q3. As we have discussed earlier, Q2 is the mean, Q1 is the middle of mean and zero, Q3 is the middle of the end value, and Q2. So box plots is specifically used for identifying the outliers. So pointing to this matplot, in this matplot, what we are doing is, as you can see earlier, as matplot approach, for this approach, we'll be having a more number of lines of code. And in Seaborn also, we'll be having less number of lines of code again. So you can understand by that. So here we can see we have some custom visualizations for access and everything. So you're mentioning a for variable and you're getting an axis. You need to identify this axis for every figure. Coming to Seaborn, these are more visually appealing by default. Okay, if you look at this, the Seaborn tends to look more colorful and more good than this like Matplotlib. Okay, so here also we are performing univariate analysis. We are performing analysis for one variable. This is for age, income, education year, experience, and satisfaction code. So whatever the variables that are outside of the, so this comes under the data points that are like these data points are the data points, but coming to these two, this might be outliers. So these two are more farther than the data points that we're having here. Okay, because of these two, we might have a bar plot. Sorry, we might have a box plot increase more. So we can specify, we can perform. So if you look at the statistical summary, like summaries and everything, we can calculate mean, median, standard deviation, and the symmetry. Whatever the symmetry we are having, if you look at this, so we can have everything by this box plot, and also we can range from minimum to maximum. So we can also, as you can see, outliers, we are defining outliers from this thing. So moving on to the next thing. So this is just for the statistical summary for the numerical variables, what you're having: mean, median, standard deviation, skewness, and range. Okay. You can perform and everything. So mean, definition of variable dot mean dot median dot std represents standard deviation dot skew of df variable. For the var function, we are performing the skew operation, and also for the range, we are getting min to max. Okay, what is the range from minimum to maximum? So that is what we are performing. You're not performing from 0 to infinity. What is the minimum value which we are having? From minimum value only, we're performing the count, and from minimum to maximum only we're taking the count. So that is what we're having for every column: age, income, education year, experience, and satisfaction score. So now we are analyzing categorical values. The numerical values has been completed. So coming to the categorical values, we're having three things: department, performance rating, and remote work. So in this, we need to understand what is having the highest value and everything. So let's turn our attention to these categorical values. So first, we'll typically use bar plots. So this bar plots will help to understand what is the values that is having more number of more number of count than other things. And also with Matplotlib, if you look at this again, we are creating manually everything. Okay, I want you to also remember that Matplotlib will, if you are using Matplotlib, you need to create everything manually. If you are using Seaborn, means you're using a library and you're fetching functions from library. So in the Seaborn, if you are looking at the functions, most of them are typically same. There is no difference. But if you're using Matplotlib, you are performing every operation by yourself. No operation is performing by Seedborn. Okay, that means in this you can see every visual is having the same data. Like you can see there is no difference between both the visuals. But coming to the Matplotlib, you will be giving the visuals whatever with Mat, like we will create the calculates like what is the count we are having. Suppose this count, whatever it is, you will be giving the values here. Okay, the count, whatever you're having, you will be giving the values. You will be setting the values here in the code. But coming to Seaborn, it will automatically set the values. As you can see, we are having some difference here. If you identify where we're getting the difference, that is because we have set the matplot to have this much value. But coming to Seaborn, based upon the data, it is giving us the value. So that is the main difference between matplot and Seaborn in bar plots. Okay, if you're performing with categorical, this is the main difference between bar plots. So the next thing we are performing is bivariate analysis. So in this bivariate analysis, we are performing with multiple categories. So if you are performing with univariable, that means you are performing for only one variable. But coming to bivariate, that means assuming what is the relation that we're having between two variables. Suppose if you are performing with sales and discount, if you are increasing the discount, you'll be having more sales. If you are decreasing the discount, suppose if you're having no discount, you'll be having a sales of 1,000 per a month. But if you're having 90% of discount, this sales of 1,000 will be increased to 5,000. That is the power of discounts what you're having in India. So if you want to increase the discount, if you want to increase the sales, you need to increase the discount. That is the relation we'll be having between sales and discount. So like that, what are the relations we'll be having between multiple columns of data that we'll be seeing in this bivariate analysis. Okay. Now first we'll be going with numerical versus numerical. In this, we are calculating the difference between age, income, education years, experience, and satisfaction score. So if the age and age, it is 1. So if the age and income, so if your age is, so this is a correlation matrix. I'll just visualize the correlation matrix for you. So then you will understand. So just run this thing. So now you can see that this is a correlation matrix. This matrix where as the age is increasing, okay, and this is the analysis of age and age, income and income, education years, experience and experience, satisfaction score and satisfaction score. Okay, so if the experience is 0.01, sorry. Okay, so imagine this matrix. So imagine we're having a matrix like this, and if you're having a satisfaction score of this thing, and that means you're having an age of higher age. So if you're having more age only, you'll be having more education experience and everything. So based upon what you are having, so we'll be having some analysis here. When you have multiple numerical variables, a great starting point is a correlation matrix. So if you're having multiple numerical variables, if you look at this 1, 2, 3, 4, 5. So 1 to 5 numerical variables are there. So first thing we'll be doing is we'll be having a correlation matrix, and after that, this table shows us how every pair of numerical variables indicates how strongly and what direction that clearly they are indicated. So we're having ones in the medium, like in the diagonal shape. That means for every age and age, we're having one. But as the age is increasing or decreasing, we're having the satisfaction score increasing or decreasing based upon what is the analysis we are having. So, okay. So if the age is 0.06, we're having a satisfaction scores of 0.01. So that is kind of analysis we'll be performing. That is a sample example which I shown, but that's not how in reality it works. So this visualization with heat map makes it much easier to digest. Okay, this color intensity will tell us the differentiation between this correlation and everything. When there is red, that is for negative. When there is blue, that is for positive. Okay, so if it is having dark blue, that means we can understand that it is a positive. So we can quickly spot what is positive and what is negative with the color difference which we are having. Okay, so this table shows that a number of every pair of numerical variables indicating them, and also a variable close to one means how stronger they have a correlation. Okay, that means if we are having, let's take an example of let's take an example of this thing, 0.06. Okay, as the experience is increasing, we are having the age. If the age is increasing and the experience is increasing, then we'll be having a stronger count. Okay, so when you're having more age, then we'll be having more experience. So at the basics, we'll be having no experience, but moving forward, we'll be gaining more experience. That is how this works. So that is what numerical versus numerical. And moving on, this is what we'll be having in numerical versus categorical. If you run this cell, you'll understand. So this is a box plot again. So in this box plot, we're trying to analyze the outliers. So as we have done in the previous session, so you can see in this. So let me just show you. Here we are using plt.show. That means we are using matplotlib. We also are using plt. That means we are not using any Seaborn library in this function. Okay, we're not using any Seaborn library. Here we are taking numerical example as income, categorical, department, and remote work. Okay, that means we are taking one numerical and two departments. Okay, one numerical and two categorical. So we are making a function. We are making a bivariate analysis of one numerical and two categorical, and we are performing some operations to get to know that what is the difference and what is the relation we are having. So if you look at this code, you can see that what we're doing is we are having a categorical example. So figure size, as for matplotlib, we need to define figure size, we need to we need to define axis and everything. So we are using SNS Seaborn to have the categorical values, everything that is defined. So we are printing the title, we are printing the label names. So this categorical labels and everything, we are printing that with the help of matplotlib. Okay, we are printing x-axis, y-axis labels, and when you give plt.show, that means we are showing this. Suppose if you remove this, now you can see that something has been missed from this figure. Now, if you remove this and run again, you can understand by this that one figure. Now, before you should have two things here. Now you can see one has been represented here and another has been represented here below. So for this matplotlib, the same applies here also. You need to define the figure size, like the categorical values where you need to place and everything. So after that, after categorical is done, where we will place in for numerical, it will automatically enter the values. So as the income is rising, okay, as the income is rising, what are the two categorical values? Department and remote work. Okay, for every department, how much of the remote work we are having. So if you can see, this much of the remote work we'll be having for box plot. If you can see, we are having multiple outliers. This one comes under outliers. This one comes under outliers. These comes under outliers. Okay, these comes under outliers. Okay, in sales, we're having less outliers as the sales are increasing. So we cannot define whether as per there is no outliers. So if you're analyzing the income, here you're analyzing income across department. Here you're analyzing income across remote work. If you're having no remote work, then you're having income less than 30,000. But if you're having a remote work, then you're having an income more than 35,000. But you're having only 1% income. But if you take a mean income, that means if you want to take an average, this average will become more than false. What are the true average income that is there? That true average income will become more than false average become income, because you'll be having more outliers. So these outliers will have some impractical income. This will have some false impact on this average of this true and false. So what we need to do is we need to remove these outliers from box plot. Whenever you find these outliers, we need to remove these outliers from this box plot. So you can understand how one variable is affecting other variable. So you can understand when the remote work we are having, then we are having more number of outliers and more number, then we can easily identify more number of outliers. And also we can understand that whenever there is the remote work of that is true, then we're having more income. Okay, that means choose a remote work, guys. Don't go for offices. And when you go for this other cell, we have completed categorical versus categorical, numerical versus numerical. Here we have completed categorical versus categorical. Now coming to the step that is categorical versus categorical. Now here we're having department, performance rating, remote work. Now we will be checking using bar plots. Okay, this is bar plots. I hope you can understand what plot this is. So we are using multiple PLT functions to define these bar plots. These are categorical examples. So we are creating tables for this. So analyzing performance rating across departments. So across departments, what is the performance rating we are having? So you can see in marketing, we are having a performance rating of 50. That is poor. So 50 people gave poor count in this marketing. In excellent, we have 80 people for marketing. Average, that is between 80 and 70, and good of between 60 to 50. So you can perform categorical. That means you can analyze which is having least number of reviews. That means you can understand that most of the excellent reviews that I got from marketing, and also most of the excellent, like least of the excellent reviews I got are from sales. Okay, and also coming to the poor, also most of the poor reviews I got from sales. That means I need to improve my sales department. Okay, these are the kind of analysis you'll be doing for categorical analysis. So if you want to performance setting across remote work, when the remote work is true, you'll be having more performance. Okay, that is, you can see, oh sorry, when you're having a remote work of true, you'll be having poor performance. And you can also see that the average performance is meeting the criteria of true and false. Coming to the excellent, if you are in true only, you'll be having more excellent performance. If you're in false, then most of you are not working. By coming to the office and not working, that means you can understand that remote work is more better than office work. Okay, these are the analysis for this categorical tables. Okay, so coming to the code, you can understand that these are the categorical examples: the department, performance rating, and remote work. So what I'll be doing is I'll be printing this thing. Okay, I'll be printing this categorical thing called name. After that, I'll be defining the figure size. I'll be using SNS to get the plot. I'll be using this title. This is for X label. This is a file label. And at the end, I'll be using plt.show to show this image. Okay, this is the same thing we should be doing here. Title for title like showing the title, X for X labeling, Y-axis labeling, and for plot you're getting SNS. That is, you're using Seaborn for getting the plot, and for figure you're defining the figure size, and it is for printing the name, that is analysis performing rate something blah blah blah. So this is the tables which I have printed in the bottom. Okay, don't confuse, guys. So that is what will be learning until now. I hope you understood the topics. Like, I hope I didn't put some of you to sleep, and I hope I delivered the session in an understandable manner, as it took 8:20 and around 22 guys are in the session. I really thank you all for staying in the session until 8:22. Sorry, 8:24. And I hope you all understood this session. Guys, give me some response in the chat. I don't think you all in the session. I want to know how many of you are present in the session. So that makes me happy that thank you for being present in the session until this time. So as discussed, we'll be extending the session. I got more responses that we can extend the session. Thank you for showing so much enthusiasm. Around 65 to 70% showed that we can extend the session. And coming to the Q&A. So that's it, guys. I'll be sharing these collab files, work on this univariate and bivariate. In the next session, we'll be discussing about multivariate. And right after that, we'll jump into the machine learning basics. So these are also the machine learning basics, but these are how you will be performing the project. But coming to the machine learning topic basics, that is what is bias, variance, variance, like bias, variance, trade-off, overfitting, underfitting, ensemble learning, transfer learning, everything we'll discuss from the next sessions. Okay, we'll go for theoretical parts from the next sessions, and the operations, functions, and everything that's completed until now. We'll only discuss the multivariate analysis in the next session, and after that, we'll go right into the machine learning topics. I hope it is clear for everyone. Yeah, I'll share the files. Thank you for being patient, everyone. Thank you for being in the session. I wish you all, sorry, I don't wish you, like, happy learning, and bye, everyone.